how do you try to go about, try to understand this world, flow of air and ocean currents and even growth of trees and how the changes in the landscape and so on and so forth, in the sense that we are trying to get at the understanding of what is weather, what is climate, right? So the proponent from this, what you call the United Nations Intergovernmental Panel on Climate Change, has been insisting for a very long time, by the way, since 1990. So that's close to 28 years. And they've been insisting that we don't have to understand what causes the climate to change today. And that is a very strange proposition, because they keep saying that, we don't have to worry about what the climate is doing today. All we need to be worried about, because all we are after is actually a policy prescription. Therefore, we can use so-called computer climate model to the best of our ability. They always would say something like that, but it doesn't help science, it doesn't help facts, it doesn't help to explain. It's to use the computer climate model to try to see what the rising carbon dioxide would do to the climate system. By the way, all of that sounded very reasonable. The only problem is that these folks are not interested in what the outcome are. They are not inquisitive at all. All they are interested is using this, what you call, by the way, I wouldn't even compare climate model to your knife. Your knife is fairly useful. It can chop tree, cut fruits, it can do vegetable salads, it can do so many things. It can chop meat, do meat, all this useful aspect of it. And then if you ask yourself, does the current understanding and the computer model, by the way, as a scientist, you have to ask a simple question. Is it good enough? So, how do I say that why this climate model is simply not good enough, especially in terms of making the prescription that we have to cut the carbon dioxide, and therefore what happened? Climate will not change. No more hurricane, no more polar bear dying, no more sea ice melting or growing, no more ice ages. What is it? It's actually none of that, because the climate model is just simply inadequate. It simply cannot supply the answer. Mostly related to our lack of understanding, mostly also related to what we have not able to account for in the climate model. It's very simple. You take a sphere. You try to create what you call grid boxes of certain sizes. So on the what you call X and Y axis, you have something like 100 kilometers by 500 kilometers. And then on the vertical part, you maybe have all the other 1 kilometers. So you try to build the climate model in this three-dimensional sphere. And then you try to put in some equations, right? Mathematical equations, just basically to track all the heat going one place or going to the ocean or going to north and south and going to the west when the wind is blowing, and all that. You try to account for all of that. But the problem is we really don't understand how the ocean works well enough. We don't understand how the cloud works well enough. Never mind that. You can ask some very basic question. Does the climate model even include the effects of the moon? Moon is our nearest neighbor. It's very important. Just go out to the coastal area, you will see. Stand there. Sorry, don't be a Mark Twain guy. You just stand there and watch the tide coming in and out. You will see that the tide is influencing that. By the way, for those who say that the tide have nothing to do with the climate system, good luck, because it does. Okay, the tidal effect is fairly important. It makes how the water in the coastal area shallow, taller and broader. In some places like Bay of Fundy in Canada, what you guys want to know what the tide level is of the order of 100 meters. This is that big of changes, okay? So it depends on where you are. These things are very, very important for local and regional climate, okay? And it's really, really important to have it right. So, again, that's why the analogy of knife and this chopping knife and this model is just nowhere close, because it's missing, first of all the physics, the chemistry, and biology. Because the famous physicist from Princeton at Institute of Advanced Study, where Professor Albert Einstein is, a professor named Freeman Dyson, who, by the way, doesn't have a PhD, but he doesn't need a PhD because he's smart enough, he's thinking. He often say that computer climate may be reasonable in the sense of how they try to solve this physics and mathematical problem. But what they're lacking is basically trees and fish and all this other biological life in the system. They don't have that. Because if you start talking about atmospheric carbon dioxide, you immediately run into the trouble is that what is governing the level of carbon dioxide in the system is actually the biosphere. This is what we need. And they haven't been even come close to try to model those things or put something into their model so that you can account for that aspect of the problem. So in the overall picture, to put a long story short, computer model is really, really terrible in the sense of being able to tell you anything, I'm sorry, because it wouldn't even tell you the season in that sense, because there was a long argument, by the way. I have met a great professor by the name of Professor Alan Robock. He's at Rutgers University now. He was extremely arrogant. He come up to me, but the computer model no seasonal cycles. I say, no, not really. Show me which computer model that can predict the seasonal cycles. Show me. Because we already learned the hard way. We know that trying to predict winter, how harsh or how strong it is very, very strongly dependent on how well you understand the system. You know, the next summer, you want to predict the droughts, the seasonal droughts. We know summer is coming. That's all we know. But I'm sorry, do you know how much rain you're going to get in Texas, or how much snow you're going to get in Canada, Montreal? What are you talking about? You actually don't. One of the most key elements about this aspect of overusing or abuse of the computer climate model is actually the arrogance. The arrogance of the practitioner, and mainly because perhaps they are too eager to sell their products, flawed products, to the policymaker, saying that, well, we know this, we know how to handle. Willie Soon, he doesn't know physics. He never take a physics class. He's not even anything. He's just a corrupted guy. But heck, I'm serious as hell about all this model having problems. Okay, they are not capable of even studying just the effect of rising atmospheric carbon dioxide, because you know why? They're not able to handle so many things, including, like I mentioned, cloud very quickly. Never mind even the complexity of cloud field, how you form cloud from water vapor, from ice, from downdraft. Basically, motion is also very important. So because if you look near coastal region of all the continents, that's where most of the clouds are formed, simply because of the land-sea boundary where you have downdraft, basically, is to form a very stable inversion of the temperature, so you can have this sort of moisture to trap there. Instead, it ultimately will form cloud, right? That's basically some of this stuff that, yes, the physics is understand, we try to model it, we did the best we can, you can cry all you want, but it doesn't matter. When it comes down to actually what the measurements say and what the model produce, the model failed 100%. It's not 99%, 100%. So therefore, the computer climate model have no use or whatsoever, for that class of problem. We're just unable to do that. I do want to make a very strong point. It's a very different one from, let's say, numerical weather prediction. This is where the mismatches of knowledge and actually the limited use of numerical weather model, or it's essentially a climate model now. The same class of model. What they did is a very different thing. They are simply trying to see how the system, the climate system, from a given current state, now, presently, we have enough information. We fed in all the satellite information, anything that we have observation, as much as we can. And then we try to let so-called the equation evolve. Again, you don't account for biology, but good enough in the sense that the system has some inertia, so it remembers something. Okay, if the wind starts blowing here, it cannot all of a sudden go left, go right. No, not so simple, right? So you try to use the equation in a proper way. Those are the good use. And for some of the more sophisticated audience, you may understand already, all these weather forecasts, they were always telling you that we are only good up to, why do they only show a week? Not because they don't want to show you the next month. It's just simply because this numerical weather prediction has a strong limit of not knowing something ahead of time without given the current condition. So they are only able to integrate this equation and this model up to, let's say, 2 weeks ahead of time. That's about it, right? I mean, this is why doing weather versus a model is completely different beast. And the arrogance of those so-called climate modelers and all this what you call DAW alarmists is indeed, they fall into the trap of their own self-delusion, if I may say so, for failing to acknowledge that actually their climate models is not worthy of that process. And my criticism comes with a very strong experience, because I have personally built some climate model myself. And because That's the best way to understand. You don't criticize something until you try to make an attempt. So can Willie Soon make the best model that can predict the future? No, I cannot, because it's just too hard of a problem. At least I admit that problem, but I'm not going to sell to the politician or just because I want to get more grant that I know how to solve the problem and the problem is already solved. Interestingly, the problem is already solved. Please stop the funding. That's where the DAW people will be very, very scared, because they're going to say, no, we need to add in one more component. We forgot the tree. We forgot this. We forgot that. We're going to add this individual component. That's how they sell it. And to do science in such an hodgepodge manner is really scary in that sense. It's really damaging for the whole general problem of science and how science should be treated and how science should really work, not be corrupted by any other forces except for evidence and truth.